Welcome back. Let us see another problem on calculation of electric flux. Problem number 2. What is the net flux of the uniform electric field E bar equals to 3 multiplied by 10 raised to 3 I cap newtons per coulomb through a cube of side 20 centimeters oriented so that its faces are parallel to coordinate planes. Also find the charge enclosed by the cube. So in this problem we are given with some electric field and we have to find flux due to that electric field through a cube which is kept in such a way that its faces are parallel to coordinate planes. And we also have to find the charge enclosed by the cube. Alright, so let's note down the value of electric field, which is 3 multiplied by 10 raised to 3 I cap newtons per coulomb, and side of cube suppose it's A, which is 20 centimeters. So we'll convert it to SI units. It is 20 multiplied by 10 raised to minus 2 in meters, which is 0.2 meters. Now let us try to visualize this electric field and the cube. So this is our coordinate system, x, y and z coordinates. Now this cube is kept in such a way that its faces are parallel to coordinate planes. That means we have to keep it something like this. Alright, and the electric field is directed along x-axis. So this is my electric field E bar, and it is uniform electric field, and you can see that it's directed along this x-axis. Now let's name the cube. So it is A, B, C, D and E, F, G, H. So we can see that the electric field lines will pass through the face A, B, C, D and face E, F, G, H only. For other faces, the faces and electric field lines are parallel to each other. So electric field lines won't pass through the other faces. So we have to calculate the electric flux for face ABCD and EFGH only. Now we know that the electric flux I is E bar dot A bar, and area vector for a closed surface is outward normal to the closed surface. So for this face, area vector would be directed like this, and for this face it would be directed like this. So let us call this A1 bar and A2 bar. So here we can say the flux is E bar dot A1 bar plus for this face the flux is E bar dot A2 bar. And it's quite clear that the magnitude of this area vector and this area vector is same, since all sides of a cube will have same area. So magnitude of A1 bar is equal to magnitude of A2 bar, and that is equal to, let's say, A. So we can write this as E into A multiplied by cos of the angle between E bar and A1 bar, which is theta 1, plus E times A into cos of the angle between E bar and A2 bar, which suppose theta 2. Then theta 1 should be equal to 180 degrees, since the electric field lines here and area vector, they are directed in opposite direction, and theta 2 should be 0 degrees, since E bar and A2 bar, they are directed in same direction. So theta 1 is 180 degrees. We can take E and A common. This cosine of 180 degrees plus cosine of 0 degrees, and which is E times A into cosine of 180 is minus 1, cosine of 0 is plus 1 minus 1 is 0. So the flux is 0. Okay, so we have found the flux through this cube. Now we have to find the charge enclosed by the cube. So how do we find the charge given the flux? We know the Gauss's law. Gauss's law says phi is equal to charge enclosed divided by epsilon naught. So charge enclosed is phi times epsilon naught. Since phi is 0, we can say that charge enclosed is also equal to 0. Okay, so there is no flux through this cube due to this electric field, and also there is no charge enclosed by the cube.